Hello, everyone. Thank you for taking the time to attend today's webinar series on operational excellence, gain visibility and control of your enterprise infrastructure. My name is Eric Weber, and I am a Senior Specialist Solutions Architect here at AWS. To go over a quick agenda of what we will be discussing today, first we'll be starting with an overview of what is AWS Systems Manager. Then we'll be talking about several Systems Manager capabilities such as Quick Setup, Explorer, OpsCenter, Automation, State Manager, and Maintenance windows. Following that, we'll go into the AWS Management Console for a brief demonstration of those capabilities. After that, we will then talk about how to centralize patch management operations within your environment, where we will discuss patch baselines, the overall patching operation, and covering a sample reference architecture. We'll then go again into the AWS Management Console for a demonstration. So what is AWS Systems Manager? What are some of the benefits of using this service? So AWS Systems Manager helps you quickly view operational data for groups of resources so you can quickly identify any issues that might impact applications that use those resources. Resources can be grouped by applications, application layers, productions versus development environments, or anything else that you choose. Systems Manager presents this operational data for your resource groups in a single, easy-to-read dashboard, so you don't have to navigate to multiple AWS consoles. For example, if you have an application that uses Amazon EC2, Amazon S3, and Amazon RDS, you can use Systems Manager to create a resource group for the application and easily see the software that is installed on your Amazon EC2 instances, any changes that occur within your Amazon S3 objects, or database instances that have been stopped. Systems Manager also enables you to automate operational tasks to help make your teams more efficient. With automated playbooks along with rich text descriptions, you can help reduce human error and simplify maintenance and deployment tasks on AWS resources. You can use predefined automation playbooks or build your own to share for common operational tasks, such as stopping and restarting an EC2 instance. Systems Manager also has built-in safety controls, allowing you to incrementally roll out new changes and automatically halt the rollout should errors occur. Systems Manager also helps you easily understand and control the current state of your resource groups. With Systems Manager, you can view detailed system configurations, operating system patch levels, software installations, application configurations, and other details about your environment through the Systems Manager Explorer and inventory dashboards. Systems Manager is also integrated with AWS Config, so you can easily view changes across your resources as they occur over time. With Systems Manager, you can also manage servers running on AWS and in your on-prem data center through a single interface. Systems Manager securely communicates with a lightweight agent that is installed on your servers or VMs to execute management tasks. This helps you manage resources for both Windows and Linux operating systems running both on AWS or on-premise. And lastly, Systems Manager helps maintain security and compliance by scanning your instances against your patch, configuration, and custom policies. You can define patch baselines, maintain an up-to-date antivirus definitions, and enforce firewall policies. You can also remotely manage your servers at scale without having to manually log into each server. Systems Manager also provides a centralized store to manage your configuration data, whether it's plain text, such as database strings, or secrets, such as passwords. This allows you to separate your secrets and configuration data from your code. To get started with the first capability, we're going to be talking about Systems Manager Quick Setup, which enables you to set up best practices within your environment. When you're using Quick Setup, there's a couple different types of configurations, which we'll take a look at once we're over in the console. You can use Quick Setup to quickly get started with Systems Manager and enable scanning for your instances to check for missing patches daily. You can automate the process of updating the Systems Manager agent. You can set up inventory data gathering for your managed instances to collect information such as applications that are installed or drivers that are installed. You can optionally also install and configure the CloudWatch agent, as well as create and configure, as well as associate the appropriate IAM instance profile roles and attach those to your EC2 instances if they are missing them. This also can be configured to deploy across your entire AWS organization so that you can specify the specific AWS accounts or organization units or OUIDs where you want to deploy out these configuration details. Like I mentioned before, you can also leverage Quick Setup to set up two other configuration aspects, including setting up Change Manager and AWS Config Recording. The next capability that we'll be talking about is Explorer, which provides an operations dashboard, which allows you to then take actionable insights. So Systems Manager Explorer is a customized operations dashboard that reports information about your AWS resources. Explorer displays an aggregated view of operations data, or ops data, for your AWS accounts and AWS regions. In Explorer, this ops data includes metadata about your Amazon EC2 instances, details from AWS config, details about your support cases, patch compliance details, trusted advisor checks, operational work items or ops items, and security hub findings. Explorer provides context about how these ops items are distributed across your business units or applications, how they've been trending over time, and how they vary by category. You can then group and filter information in Explorer to focus on items that are relevant to you and that require action. When you then identify high priority issues, you can use Systems Manager OpsCenter to run automation runbooks and quickly resolve those issues. Speaking of OpsCenter, OpsCenter enables a standard and unified experience for viewing, working on, and remediating issues that relate to your AWS resources. By providing a standard and unified experience, OpsCenter helps improve the time it takes to remedy issues, investigate related issues, and train new operations engineers and IT professionals. It also helps reduce the number of manual errors that can be entered into the system by leveraging these automation runbooks to perform tasks automatically. More specifically, OpsCenter offers the following benefits for operation engineers and organizations. You no longer need to navigate across multiple consoles in order to view, investigate, and resolve ops items related to your AWS resources. Ops items are aggregated across services in a central location. You can view service-specific and contextually relevant data for these ops items. These are automatically generated based off of CloudWatch alarms, event bridge rules, or security hub findings. You can specify the Amazon resource name, or ARN, of a resource that is related to an ops item. By specifying these related resources, OpsCenter then uses built-in logic to help you avoid creating duplicate ops items. You can view details and resolution information about similar ops items. And then based off of that information you've been reviewing, you can then quickly take action using the Systems Manager automation runbooks to resolve issues as they occur. OpsCenter also has bi-directional integration with Jira Service Desk, as well as you can leverage these APIs to integrate with your existing case management systems. These automation runbooks that I've been talking about, these help you eliminate the manual effort for those common tasks that you may be performing by leveraging either AWS pre-provided documents or custom automation runbooks that you end up creating. You can build out these automation workflows in order to configure and manage instances or even AWS resources. These custom workflows or these predefined workflows, you can configure them to receive notifications about their execution status so that you are alerted should anything fail or if you are interested in these overall success. You can monitor the overall progress and execution details either by using the management console, querying it from the API, or again, using event bridge rules. Some of the common use cases of leveraging automation include performing common IT tasks, such as simplifying the state of one or more instances using an automation approval, or managing instance states according to a particular schedule. You can also safely perform disruptive tasks in bulk by leveraging those rate control and concurrency options that I was talking about earlier. By leveraging these velocity controls, it can help you roll out those changes on a safe basis according to the limits that you define. Automation also offers one-click automations for simplifying complex tasks, such as creating golden Amazon machine images, or AMIs, or recovering unreachable EC2 instances. Automation also helps enhance operational security by using delegated administration. You can then restrict or elevate user permissions for various different types of tasks. And these runbooks that you are creating, you can then help share best practices within your organization by sharing out these runbooks across your different accounts and different environments. The next capability that we're going to be talking about is State Manager, which helps provide a secure and scalable configuration management for your AWS resources. State Manager, within State Manager, you are going to be creating what are called associations, which are associating a document with your specified resource, typically a managed instance within Systems Manager, but this can also be other AWS resources within your account. Common types of tasks that you can perform with State Manager include bootstrapping instances with specific software at startup, downloading and updating agents on a defined schedule, configuring network settings, joining instances to a Microsoft Active domain, patching instances, and checking for daily patch scans, running scripts on Linux and Windows instances throughout their lifecycle. And State Manager also integrates with AWS CloudTrail to provide a record of all executions that you can then go back and review or monitor and track those state changes using EventBridge rules. You can also configure the output operation so that those execution logs are stored within an Amazon S3 bucket. And another great use case is when you stand up CloudFormation stacks, you can also create a corresponding State Manager association so that those instances or resources that you provision using CloudFormation can then have a State Manager association immediately be applied post-provisionment. The last capability that we'll talk about in the first section are maintenance windows. So maintenance windows let you define a schedule for when you want to perform potentially disruptive tasks on your managed instances, such as patching an operating system, updating drivers, or installing software. Maintenance windows also lets you schedule other types of actions on numerous other AWS resource types, such as Amazon S3 buckets, Amazon SQS queues, AWS KMS keys, and many more. You can use these maintenance windows to perform tasks similar to installing missing updates, which we'll talk about more in the patch management section. You can use this to build out Amazon machine images or AMIs, and then configure instances using that same AMI. You can run AWS Lambda functions that can then go and perform actions within your environment based off of a cron array-based expression. You can also run AWS step function state machines to perform tasks such as removing an instance from an elastic load balancing environment, patching the instance, and then adding that instance back into the ELB. You can also use maintenance window to kick off automation runbooks that can target instances that are offline by specifying an AWS resource group as the target. So to get started with the first demonstration, we're going to flip over into the AWS Management Console. So in the AWS Management Console, we're going to go over to the Systems Manager console. Within the Systems Manager console, we're first going to take a look at Quick Setup. So in Quick Setup, like I was mentioning, there are a couple different options that Quick Setup can help you get started quickly with. Those configuration types are going to be a host management option, enabling AWS config recording, or setting up Change Manager within Systems Manager. Today, we're just going to take a look at the host management option. So within Quick Setup for the host management configuration, like I mentioned before, you can get started quickly with Systems Manager best practices, which will keep the SSM agent up to date every 2 weeks. It'll collect inventory data from your instances every 30 minutes, and it'll perform patch scans daily to check for missing updates. Each of these can always be enabled or disabled, so you have the option to modify. You can also choose to install and configure the CloudWatch agent, as well as keep the CloudWatch agent up to date. And then this will also enable Systems Manager Explorer to aggregate data from our multiple accounts in multiple regions. When we are going through our configuration options, we can then scroll down to the target section, where we can either specify that we want to target our entire AWS organization. We can specify specific OUs within our organization, or we can say that we only want to deploy this to the current account. Now we'll just go ahead and revert it back to the entire organization. The last option is that when you set up Systems Manager Quick Setup, there's going to be a State Manager Association, well, several State Manager Associations that are created, which are going to be based off of the configuration details that we defined above. One of the options that we can include here is we can specify that if an EC2 instance already has an existing IAM instance profile role, but it doesn't have the required permissions to leverage Systems Manager, then the automation capability can then attach the appropriate IAM policies to that existing role, which can help ensure that your instances are checking in with Systems Manager. For now, I'm just going to hit cancel since I already have one created. All right, to take a look at one of those previously created quick setup configurations for my host management, we're going to select it from the list and hit view details here. And in here, we can see the configuration deployment status of our CloudFormation stack sets, across each of our accounts and regions, as well as the overall association status, whether they were all successful, if there are any that are failed, or if any remaining as a pending state. So we're going to open up one of the associations in order to get the details of the state manager associations within that given account and region. So we can see in here that based on the quick setup configuration that I specified, each of these associations are now in a successful status, how many instances they were applied against, what is their scheduled rate, and when was that information last updated. So we can see that the update SSM agent, attach IAM to instance, enable Explorer, and scan for patches, each of those were performed successfully. So now we're going to go over to one of those accounts and actually log in to see those state manager associations. All right, so now I've switched accounts into one of those target accounts. So let's go over to the Systems Manager console. And like I mentioned previously, those quick setup configurations are going to create corresponding state manager associations. So let's go to the State Manager console. And then in here, we can see each of those quick setup processes for each of those options that I selected. So in this case, our quick setup process for updating the SSM agent. We have our quick setup process for creating and attaching the IAM role to our managed instances, enabling Explorer, and then running a daily patch scan operation. So we could open up each of these individual state manager associations to see some more details about it. Again, which resources does it end up targeting? What are those parameters that are being passed in? And what is the overall execution history for each of those operations as it's being performed based on the cron or rate-based expression that is defined. And then now that we've looked at the association itself, we can also go back to our management console and go to the CloudFormation console in order to see those corresponding stack sets. So within CloudFormation, we're going to go over to the stack set section. And this is where we can see that corresponding stack set for our quick setup host management process. So in here, we could always go to the template tab in order to see the corresponding JSON format of our template. We can see the parameters that were defined as part of that quick setup wizard process. We can see the specific accounts and regions where each of these stacks have been deployed into. And then just see the operations as part of the overall quick setup process if you made any modifications to the OUs that you may have been targeting or the regions where the quick setup process was deployed into. Now that we've reviewed quick setup and these state manager associations, we can then go to Explorer to review that aggregated data across our organization. So before I go through the dashboard itself, we're going to take a look at some of these settings. Specifically, when we are working with the Explorer dashboard, we can configure a data export, which is going to be an S3 bucket, where we can export the information that is populated as a CSV file. We can also include an SNS topic so that we are alerted when the export process has completed. Within Explorer, you can specify a child account within the AWS organization to be a delegated administrator. You can include up to 5 resource tags, which can then be leveraged for ops data filtering within the dashboard itself. And then down here in the last section is the resource data sync. So the resource data sync is where we will define which accounts and which regions within our organization we want to collect information from. We can either choose just to include all accounts within your overall organization, or optionally, when you are creating the resource data sync, you can specify that you want to only include data from specific organization units. And within Explorer, you can create multiple resource data syncs. So you can always have one that is looking at the entire organization, and then you can have other resource data syncs, which can provide a more filtered view for specific organization units. Beyond that, we're just defining which regions we want to collect information from. Within Explorer, like I mentioned previously, it aggregates a lot of different details from various AWS services. So each of these we can enable or disable based off of our choosing. And if we go to the dashboard itself, we can then take a look at all these relevant data points, such as information that is pulled from AWS config, highlighting how many of your config roles are compliant versus those that are not, as well as which resources are compliant and those that are not. It'll also pull in how many of your EC2 instances are checking in with Systems Manager versus those that are unmanaged. Those resources that are managed, you want to be sure that you are remediating those so that you can then perform other operations like performing those patch scans daily and check in. It'll also aggregate data from Systems Manager OpsCenter, showing how many of your ops items are open and their status, and as well as their severity values. And then aggregate information from Security Hub as well to highlight how many Security Hub findings you have across your accounts. It'll also pull information about support cases that have been opened up recently, how many of your EC2 instances are compliant for patching. This next section is, again, for OpsCenter, listing out those ops items over time, how many instances you have across your various accounts, how many instances are using a particular AMI, aggregating data about trusted advisor checks, and then down here, we have 2 more widgets showing desired state configuration for our state manager associations, which we're leveraging those quick setup functionalities, and then those ops items, grouping them up by their summaries or their ops item source. So now we're going to focus a little bit more over in the OpsCenter capability. Within OpsCenter, we can see how many ops items we have created. In this case, if I go to my configuration sources, like I mentioned previously, there's a couple different ways that ops items can be created within OpsCenter. The first is that you can include a direct alarm action based off of CloudWatch alarms. So when they change to the alarm state, you can then have a corresponding ops item be created. You can also enable automatic creation of ops items based off of Security Hub findings. You can filter based off of specific finding levels. And then the last section, these ops item rules, these are based off of event bridge rules. So based off of events that take place within your account, you can then have a corresponding ops item be created. And these ones that are listed out here, these are the default pre-provided ops item rules, which you can always enable or disable as needed. So an example being this EC2 schedule changes. So when there are schedule changes that are posted to your EC2 instances, you can have a corresponding ops item be created within your account. For today, we're going to go back to OpsCenter, and then we're going to take a look at the CloudWatch alarm. So in this case, earlier today, it looks like there was a CPU alarm that was triggered. So in here, I have the resource ARN values of both my CloudWatch alarm as well as the corresponding EC2 instance, which had the CPU spike. If I expand my operation details, I can see when was this alarm created, as well as when was it last updated. See the overall severity and the performance, or the category. You can also choose to include SNS notifications, so when ops items are created, you can then be alerted. If we scroll down through here, we can see if there were other similar ops items. In this case, it looks like there were some other related ops items, but they have been resolved. If we go to the related resource details tab, we can then see where OpsCenter is aggregating data from those other AWS sources that I was mentioning. When we are looking at the CloudWatch alarm itself, we can expand to quickly see what is the alarm threshold and what are some of the current metrics that are being posted. If we scroll through, we can see what was the history of that CloudWatch alarm and how it has been changing over time. We can also see CloudTrail logs, as well as details from AWS config for this CloudWatch alarm. If we scroll back up, we can then change to the EC2 instance itself and see some details pertaining to the managed instance. Again, reviewing data from CloudWatch metrics that are being pulled in. If we scroll through here, we can see some of the information that is being populated by the EC2 console and being pulled in by OpsCenter. If we continue to scroll through here, we can see those current CloudWatch alarms, details that are being pulled in from AWS config, AWS CloudTrail, as well as any information that is pertaining to the CloudFormation stack where this resource was created from. In this case, we can also specify that we want to open up a session using Systems Manager Session Manager. So Session Manager allows us to quickly establish an interactive PowerShell-based session on Windows or a shell-based session on Linux, where we can then interact with the operating system without having to establish a full remote connection. So in here, we can now run commands against our managed instance, as well as receive the resulting output. Another benefit of using Session Manager is that it does not require inbound rules within our security groups. Additionally, we can also stand up VPC endpoints so that your instances can communicate directly with the Systems Manager endpoints, so it does not require internet-based access. But for now, we'll just go ahead and hit terminate and go back to our OpsCenter ops item. The last detail in here, just to highlight for now, is if we go back to the Overview tab, we can select our EC2 instance. We can scroll down to this runbook section. So in the case of a CPU alarm being triggered, maybe through that session manager session, we determined that there's a process that is running awry. Maybe it makes sense just to go ahead and restart the EC2 instance. So we can select our automation document here and just hit execute. And it's going to fill out our instance ID, and we can just go ahead and hit perform. So this is going to kick off an automation operation to go ahead and restart that EC2 instance. And after that, we would then expect that our instance, as well as that CPU alarm, is resolved. All right, so now we're going to go ahead and move along to the centralized patch management section. To get started, first we're going to talk about Patch Manager, one of the capabilities of Systems Manager. So you can use Patch Manager to apply patches for both your operating systems as well as applications. You can patch fleets of Amazon EC2 instances as well as your hybrid managed instances, whether those are servers and VMs, based off of their operating system type. This includes supported versions of Windows Server, Ubuntu Server, Red Hat Enterprise Linux or RHEL, SUSE Linux Enterprise Server or SLES, CentOS, Amazon Linux 2, and Mac OS. You can scan instances to see only a report of missing updates, or you can scan and automatically install all of those missing updates. Patch Manager uses the concept of patch baselines, which are going to include rules for auto-approving patches within days of their release, or based off of a cutoff date, as well as lists out the approved and rejected patches. You can then install patches on a regular basis by scheduling those operations, which we'll take a look at in a moment. You can also install patches individually or to a large group of instances using their resource tags, resource groups, or specifying all managed instances. Patch Manager also integrates with AWS Identity and Access Management, or IAM, AWS CloudTrail, and Amazon Event Bridge rules in order to provide a secure patching experience that includes event notifications and the ability to audit usage. To get started, first we're going to cover those patch baselines that I was talking about earlier. So patch baselines are used to define the criteria for the type of updates that you want to scan or install for during patching operations. Patch baselines are operating system specific, but you can create multiple baselines for the same operating system. The reason that you may want to do that is that you may create different patch baselines for different subsets of resources within your environment that require different sets of updates compared to others. For example, you may have different patching criteria for your database servers or Active Directory domain controllers compared to your web application servers. So you want to make sure that you are creating specific patch baselines for each workload. Each baseline rule also has its own compliance reporting level that can be specified, and this allows you to quickly identify at a glance the patching state of your environment. For Windows workloads, patch baselines support patching both the operating system updates as well as Microsoft application updates, such as Exchange Server, Microsoft Office, Silverlight, Microsoft SQL Server, and more. For Linux workloads, you can choose to install non-security updates in addition to security updates. Additionally, for Linux, you can specify an alternative repository to be used during patching operations. And the alternative repository will override the repo configurations within the operating system. One thing to keep in mind when using Patch Manager is that your instances must have access to a repo in order to scan and install updates. This can be remote repositories such as the Microsoft Update Catalog in the case of Windows, or the Red Hat Update Infrastructure, or RUI for Red Hat. Or your managed instances can leverage internally hosted repositories within your environment, such as a Windows Server Update Service, or WSUS, Red Hat Satellite Server, or a VPC endpoint connection for an S3 bucket for Amazon Linux and Linux 2. Lastly, within your baseline rules, you can specify an explicit exceptions that need to be made. These can either be explicitly approved patches or explicitly rejected patches. Rejected patches can either be flat out blocked and never installed, or you can specify that they're only allowed to be installed as a dependency for an approved package. After you define the criteria for the types of updates you want to scan for or install using patch baselines, you're then ready to begin performing patching operations. Patching operations can either be invoked on an ad hoc basis or occur on a scheduled basis. When performing these patching operations, you're primarily going to leverage two AWS provided documents, AWS Run Patch Baseline, or a recently released document called AWS Run Patch Baseline with hooks. Within the document AWS Run Patch Baseline, you can optionally specify an install override list, which is, as the name suggests, allows you to provide a JSON or YAML formatted specific list of packages that you want to install, which is going to override your baseline criteria. This provides a very granular approach to installing a small set of updates without having to modify your patch baseline rule criteria. When you choose to perform an install operation, you have a few options around the reboot behavior. You can specify to reboot the managed instance if needed, meaning if approved missing updates are installed, then Patch Manager will enforce a final reboot. Or you can specify that patches should only be installed without rebooting the managed instance. You can then also schedule a later point in time to reboot the instance. You can target your managed instances for patch scans or install operations using resource tags, resource groups, specific resource IDs, or target all managed instances. After the patching operation completes, whether it was a scan or an install, you can then specify to have the command output logs to be stored either in Amazon S3 or CloudWatch logs. A new feature that was added previously this year is called Lifecycle Hooks, which leverages the document AWS Run Patch Baseline with hooks. This document allows you to run commands and scripts using command documents, which can be called at various points during the patching operation. For example, you can run a set of commands before patching installation to gracefully stop applications and services on your managed instances. You can then run a different set of commands to update applications immediately after patching. And lastly, if you choose to reboot your managed instances, then you can run a set of commands after the instance comes back up to start applications and verify their application health. Before we move into this sample reference architecture for multi-account, let's discuss reporting within the same account and region. So I open up the Patch Manager section of the Systems Manager console, and in here we can see a couple different widgets that provide some high-level overview information as far as the current patching state of our instances, whether they are compliant with the patch baselines that we defined, if there are any instances that have patches that are missing, failed patches, or those that are still pending a reboot. Additionally, you can see how fresh that patch data is in the compliance reporting age. And this will also highlight any managed instances that you have that have never reported patching compliance results. If we scroll through here, you can see some of those previous patching operations that you may have kicked off, as well as some of the common reoccurring patching tasks that you have within your environment. We can also navigate to the reporting tab in order to get a CSV file that will be exported out to an S3 bucket that will contain details about our current patching state. You can either select an individual instance from the list, or if you want to get a summary view, you can just select Export to S3. In here, we'd be filling out our report name of the patching report. And this can either be generated on an on-demand basis, meaning a one-time operation, or we could set it up to be performed on a schedule using a cron or rate-based expression that we define. For now, I'll just select on-demand. And then, like I mentioned before, it'll export it out to an S3 bucket. So we'll select that from the list and just go ahead and hit submit. So this is now going to start exporting out that information into my S3 bucket, where I can then pull up my bucket and review that corresponding CSV file. So now my process has completed, so I can select View Report here. And this will then open up that deep link over to the S3 bucket where that CSV file is located. So in here, I can then just select Object Actions and Open. And this will download the CSV file where I can then open it up and take a look at those corresponding results within Excel. So this is a way to quickly get that summary information about the current patching state of your instances within the same account and same region. So now we're going to go back to the presentation to talk about how this can be configured within a multi-account approach. Now, the main focus of the demonstration that we're about to go into will be covering this sample reference architecture. So at the bottom of the page, there's a bit.ly link, which you can click in order to navigate to the GitHub repo where the sample reference architecture is hosted. This architecture is based off of scheduling using an Amazon Event Bridge rule, which is going to be a cron or rate-based expression that you define. That is then going to in turn invoke an AWS Lambda function, which will kick off our multi-account and multi-region automation workflow. In this case, you can specify whether you want to perform a scan or install patching operation. We're going to target our EC2 instances or those hybrid managed instances using a resource group. That information, based off of what patches are being marked as missing or successfully installed, will then be aggregated centrally into an Amazon S3 bucket using a resource data sync within Systems Manager. That information within the Amazon S3 bucket can then be aggregated into a database and table using a AWS Glue crawler, which you can then query using Amazon Athena and visualize using Amazon QuickSight. So to get started with that, we're going to flip back over into the AWS Management Console. Okay, so now we're back in the AWS Management Console. And before we take a look there, again, on that slide page that was presented previously, you can navigate to the sample reference architecture, which is hosted on GitHub, and go through the table of contents, which talks about the deployment process, which we won't be covering here. We'll just be showing what is the result after we deploy our CloudFormation stacks. But to flip back over into the Management Console, we're first going to go to the CloudFormation console. And here we have a couple different stacks. In this case, we're going to focus on the operations stack. So within our operations stack, this is where we'll be creating that Lambda function, the event bridge rule, as well as our automation document. So first, we're going to open up that event bridge rule. So within our event bridge rule, we're specifying our cron or array-based expression. Like I mentioned previously, this is then going to in turn kick off our Lambda function. So let's open up our Lambda function. In this case, I'm just specifying a cron expression to kick off the Lambda function on Fridays at 9 UTC. Our Lambda function, if we then open it up and scroll down into the code, if we were to look at the code itself, this is going to be ingesting environment variables that are defined using the CloudFormation template. In particular, this is really just going to kick off a start automation execution, which is then going to perform the multi-account and multi-region automation workflow. If we look at our configuration tab, we can look at our environment variables where we have those details being specified, such as which resource group we want to target, in this case being web servers, and then which accounts we want to target, this case being 3 of those listed out. We can also use AWS Organization Unit IDs or OUIDs. And then we can also specify which regions we want to target through a comma-separated list. So when this Lambda function is then called by our event bridge rule, that is then going to kick off that multi-account and multi-region automation operation. So let's flip back to the Systems Manager console. Within the Systems Manager console, we're going to go to automation. And then in here, we can see our operation that was kicked off earlier. So if we expand some of these details, we can see we initiated the automation document that was created from the CloudFormation template. If we scroll through here, we can see each of those accounts that we ended up targeting, as well as those 2 specific regions where we targeted within each of those accounts. If we scroll down, we can see some of those other input parameters that ended up being passed in. In my case, I'm just performing a scan operation, but you can always flip this to install. And then if we wanted to drill down into one of those specific accounts, we can also do that. So we can see what was the automation execution ID within that given account and given region. In this case, there's just that single step in order to perform a run patch baseline operation with the scan parameter provided. To go back up to the root level, we're then just going to expand the description here and open up that automation document as well to take a quick look. Within our automation document, the area that I want to highlight specifically is going to be within our input parameters of our run command operation. So like I mentioned previously, we're just including a single action just to perform a run command task for the document AWS run patch baseline. In here, we are also specifying our output options for our S3 bucket, as well as the S3 key prefix. In this case, we are specifying an S3 bucket so that we can aggregate our execution logs. Once the operation completes, we then want to store those corresponding logs in case we need to troubleshoot further. Within the S3 bucket, we're specifying a key prefix in order to break up those files. And in here, we are leveraging Systems Manager automation system variables. in order to segment out those resulting execution log files. So in here, we're going to be passing in the account ID and the system variable for account ID, for region, and then the execution ID. And these variables are going to be resolved once the operation is performed within that given account and region. So they can then be automatically resolved without having to hard code them specifically. So in here, I'm also going to pull up our automation system variables documentation topic, where we can see some of those other system variables that I can include, such as date, date time, and AWS partition. So to go back to our management console, we'll then zoom back out. And now that we've performed our scan operation, we're going to take a look at that resulting S3 bucket. So within the S3 bucket, which was created based off of that CloudFormation template, we can then see our information as it pertains to patching related data, as well as the Systems Manager inventory capability and the State Manager Association compliance details. So each of these will be broken up by their various data types. When we are talking about patching related results, we'll typically be looking at in the AWS compliance item data type, compliance summary, and patch summary. Each of these data types are then broken up by the account and then the region. And then if we go all the way down to the bottom, there'll be each managed instance listed as a JSON object. Like I mentioned previously, once we have this information within our S3 bucket, we can then use a glue crawler in order to create the database and tables from it, and then query that information using Athena and QuickSight. So next, we're going to go over to the Athena console. So within Athena, we can specify that database, which was created by our glue crawler, and then we can query the information within the database. So in this case, I'm going to perform a query for the compliance item data type, specifically returning results for the patch compliance type and resources that are non-compliant with patching. Now those JSON objects that we were looking at within the S3 bucket, those will contain the very granular information as far as which specific updates are being marked as missing and what is their title. What is the overall severity and classification of those updates? What is their package identifier? What is the current patching state? If we scroll all the way over to the right-hand side, we can see the corresponding resource where that instance has the update missing. When was that information captured? And what account region does that resource reside in? For Linux-related updates, you'll also see some CVE IDs that are reported by the operating system. And this Athena information and results that we've now returned can also be exported as a CSV format. Once we have these databases and tables, and now that we performed an example SQL-based query using Amazon Athena, we may want to actually just visualize the information instead of returning and looking at these resulting table sets. So to do that, we're then going to go over to the Amazon QuickSight console. So Amazon QuickSight is a service that you can use to build out visualization around these databases and tables that we're looking at within Athena, as well as other data sources. So in this case, we're going to pull up an example patch dashboard that I created previously, which is just going to aggregate information across my AWS organization. So in this case, it's going to highlight various details about my environment, such as how many of my managed instances are compliant with patching versus those that are not. So in this case, it looks like 3 of my managed instances in my accounts are not in compliant. So I'm going to split out how many of those missing updates are categorized based off of their severity, as well as grouping them by their account ID, listing out what are some of the common patching severities that are marked as missing, and what are those accounts where those updates are missing within. If we scroll down here, just some more example information, such as grouping those up by those accounts, and then listing out each of those package titles and their identifiers, as well as the account at which they are missing. So this is just an example QuickSight dashboard that you can create. You can always customize this information further in order to populate more information. Any of that data that is listed within this S3 bucket can then be leveraged as part of the data sets that we then visualize using Athena as well as QuickSight. And with that being said, we can then go ahead back to our presentation. We're then going to just talk about a couple other alternative scheduling mechanisms that we can leverage as part of our centralized operations. So now that we've reviewed the sample reference architecture, I wanted to share two other alternative scheduling mechanisms that can be used for these centralized operations and compare each of them. Amazon Event Bridge rules can be triggered based off of the cron array-based expressions that we define, which we saw in the management console. Additionally, these rules can also be triggered as a result of events that are monitored. You can create up to 300 Event Bridge rules per event bus within a given AWS account and region. And then as we saw within the sample reference architecture, the Event Bridge rules do require that intermediary step in order to call the multi-account and multi-region automation operation, which in this case, we reviewed an AWS Lambda function to perform that step. And then to create an Event Bridge rule, you can either use a CloudFormation template, or you can create the role using our AWS CLIs, such as leveraging the AWS CLI or SDK. State manager associations differ in that you can specify a cron array-based expression for the schedule, or you can manually invoke the association on demand. Up to 2,000 associations can be created within a given AWS account and region. And in contrast with Event Bridge rules and maintenance windows, state manager associations can initiate a multi-account and multi-region automation runbook directly, so that intermediary step of initiating a Lambda function is not required for state manager associations. However, currently you can only create the multi-account and multi-region association using the AWS APIs. The last scheduling mechanism are going to be maintenance windows. And the primary benefit of using maintenance windows is that you can specify a cron offset value. This value is a number of days to wait for the maintenance window to run after that specified cron expression of date time. In a given AWS account and region, you can create 50 maintenance windows. And similar to Event Bridge rules, maintenance windows do require that intermediary step for that Lambda function. Lastly, again, similar to Event Bridge rules, you can create maintenance windows using CloudFormation stacks or by using the AWS APIs. Now that we've identified the differences between the various scheduling mechanisms, you may be thinking, which should you use in your environment? State manager associations are a great fit for performing those daily patch scans on your managed instances. Additionally, like we reviewed earlier, you can quickly get started with creating those state manager associations for those daily patch scans using Systems Manager Quick Setup. If your scheduled expression requires that offset value, then you can use maintenance windows. For example, you can specify a cron expression where the maintenance window is invoked on the second Tuesday of the month. Additionally, you can then specify that cron offset value in order to state that the maintenance window should only run 4 days after that cron expression. This means that the maintenance window will always run on the Saturday following that second Tuesday of the month instead. This value is very helpful in the case of Windows workload patching, as Microsoft has a standard release date of the second Tuesday of the month. And then finally, if you need to invoke patching operations or other operations as a result of events that take place within your AWS account, then you can use Amazon Event Bridge rules to start operations based off of those events as they occur. And with that, we are then brought to the end of today's webinar. Again, my name is Eric Weber, and thank you for attending. Please feel free to ask any questions.